First on BBC One, Patrick Moore tells tales of the unexpected as he gazes into the sky at night.
Good evening. I've often referred to Merlin, the network of radio telescopes which covers quite a large area of Britain. Well, the latest component, the large dish at Cambridge, has just been put into position. It's not functional yet, but it soon will be, and Merlin has already proved its worth. Before we go any further, don't forget next February's total eclipse of the moon. Here's a picture of the last eclipse, last August, sent to us by Norman Marks. Rather a lovely picture. But next February, we're going to have a really good display with any luck at all. The eclipse actually begins at 1730 GMT. Totality lasts from 1851 to 1933, and the entire eclipse ends at 2054. So, photographers, I suggest you get ready. It's going to be the last total eclipse of the moon for some time. Now, you know, life is full of surprises, and astronomers have them too. And therefore, I want to call this program Tales of the Unexpected. And I had a shock myself last year, and that concerned the brilliant planet Jupiter, which is now nicely on view in the evening sky, in Gemini, not very far from Orion. And you really can't mistake Jupiter, because it is so much brighter than anything else, except, of course, Venus. And Jupiter is a giant world. It has a gaseous surface, and it's always changing. Here's a fairly conventional view of Jupiter. And incidentally, in all these planetary pictures I'm going to show you, I've got south at the top, because that's the way in which ordinary telescopes show the planets. And so there we have the great red spot, and there we have the two prominent belts, one to either side of the equator. The upper one, the south equatorial, and the lower one, the north equatorial. Well, over periods, Jupiter does change. There's another view with the red spot on the far side. And here, as we can see, the view is slightly different again. But Jupiter, although it changes, doesn't often do such dramatic changes as it did in the middle of 1989. Now, here's a drawing I made with my 15-inch telescope at the start of 1989. The red spot's not there, but both the equatorial belts are. And as you can see, the upper one, the south equatorial, is probably the most prominent feature on the entire planet. When Jupiter came round from behind the sun last summer, I looked at it again, and I had a surprise. That's what I saw. The south equatorial belt had virtually disappeared, and the red spot had come back. And frankly, I've been looking at Jupiter for over 50 years, and I've never seen that kind of dramatic change before. So at the moment, astronomers are paying very close attention to Jupiter. The great red spot, of course, had been known for a long time, and there's a Voyager picture of it. It really is a huge whirling storm. As to the color, well, we're not quite sure what causes it. It could well be phosphorus, but certainly Jupiter is of special interest at the present moment. I'm sure you remember Will Hay, the stage and screen comedian, a very magnificent actor. Well, in his private life, he was also a very skilled amateur astronomer and had a fine 6-inch telescope, and there he is with it. And in 1933, he was making a routine observation of Saturn when he discovered something very unexpected and very interesting, a white spot on the planet's surface. And we don't often get those on Saturn, and when we do, they're very useful in helping us to determine the rate of rotation of the planet. And there's a drawing made by Will Hay, which he actually gave me some time later. And there is the white spot. It didn't last for long. Over the next few days, it gradually spread out and became elongated, and it became less and less distinct. And then, after a few weeks, it had merely become a bright area, and you could no longer distinguish it. But certainly, it was dramatic, and nothing quite like that has been seen on Saturn either before or since, so all credit to Will Hay. But when we come on to really unexpected events, of course, it's comets that really take us by surprise. In 1910, Halley's comet was expected and duly turned up. But in January 1910, before Halley became visible with the naked eye, a group of diamond miners in South Africa came out after a shift, looked up in the sky, and there they saw a brilliant comet. And there's a drawing of it by Percy Wilkins. And it wasn't Halley's comet. This was the so-called daylight comet, because it really was visible even when the sun was above the horizon, and it won't actually come back for a long time, many thousands of years. Halley's comet did come back in the following spring, and there's a picture of it as it was in 1910, very much brighter than it was in 1986, last time round. But Halley's comet never rivaled the daylight comet. And you know, when Halley was last round, many people came to see it through my telescopes, and a lot of elderly people said, yes, I remember Halley's comet in 1910. And I hadn't the heart to tell them that, in all probability, what they'd seen was not Halley's comet, but the daylight comet. Occasionally, the moon passes in front of the sun and causes a total eclipse. And here's a picture of a total eclipse I took from the Philippine Islands in 1988. The moon there is blacking out the sun. You can see the sun's atmosphere, and those two red patches are the prominences, masses of glowing hydrogen rising from the sun's surface. And believe me, a total eclipse is a splendid sight. You don't often see them from any particular point on the Earth's surface. From England, the last total eclipse was that of 1927, and the next is going to be on August 11th, 1999, when, if I'm still around, you'll see me in Cornwall. But in 1882, there was a total eclipse, and the track of totality crossed Egypt, and astronomers went there to have a look at it. And as soon as totality began, and the sun was blacked out, and the sky went dark, they saw, to their surprise, a bright comet near the sun. It was never seen before, it was never seen again, and so that is our only record of it, the famous eclipse comet of 1882. But in 1947, the same kind of thing happened. There was a total eclipse of the sun, that was photographed, and there you can see a bright, totally unexpected comet. But that was seen subsequently, and so we know, in fact, how it moved. But there was another comet in 1882, not the eclipse comet, which was responsible for a whole new branch of astronomy. It was a bright comet, and Sir David Gill, the director of the Cape Observatory in South Africa, decided to try and photograph it. Now, this was more than 100 years ago, and photography was fairly primitive, judged by our standards, and no one had really got a good photograph of a comet, so Gill decided to try. He enlisted the aid of a photographer friend, and they fixed up equipment, used their telescope as a guide, and they took this picture of the bright 1882 comet. But the unexpected thing about it, from Gill's point of view, was that as well as showing the comet, which it does beautifully, there are hundreds upon hundreds of background stars. Now, at that stage, the stars had been mapped by laborious physical measuring. And as soon as he saw that picture, Gill realized that the best way to map the stars was not by visual observation, but by photography. And so that one photograph, which caused Gill such a surprise, led on directly to the great photographic star atlases of today. But still on comets, what about a comet which splits in half? And that's what happened to Biela's comet. It was originally found in the last part of the 18th century, and then in 1826 it was seen by Wilhelm von Biela, after whom it's named, and it turned out to be a fairly bright comet as periodical comets go, just on the fringe of naked eye visibility, and it had a period of revolution of 6 3/4 years. Well, it came back on schedule in 1832. It was missed in 1839 because it was badly placed in the sky, almost behind the sun, but it came back again on schedule at the return of 1845-46. And then it did a very unexpected thing. It split in two. Well, we haven't, of course, got any photographs of it. It was before the age of photography. But there's a drawing made by Angelo Secchi, and you can see the twin comets. And nothing like that had been seen before. So the return of 1852 was eagerly awaited. And sure enough, back came the two parts of Biela's comet, still going around the sun in tandem, and still obviously together. 1859, they were missed again because it was badly placed. But in 1865-66, they should have been ideally placed. And astronomers began watching well ahead of time. And they wondered, what are the two Biela's comets going to look like now? Well, they watched, and they watched, and they watched, and absolutely nothing happened. Biela's comet did not appear, and it's never been seen since. And so undoubtedly, Biela's comet no longer exists. It has broken up. But still, there was a further watch at the next scheduled return, that of 1872. Once again, there was no comet, but this time there was a brilliant shower of meteors, or shooting stars, coming from that point in the sky where Biela's comets should have been. And there's the only drawing that I know of that shower of 1872. And that showed that meteors are cometary debris, and what we were seeing was the funeral pyre of Biela's comet. Now, meteors of a particular shower go around the sun in parallel paths, and that's why the showers, meteors, seem to come from one particular point. A little while ago, I stood on a bridge overlooking a motorway, and I took that picture. Now, obviously, the lanes of the motorway are parallel. And if you had cars coming towards you down all the lanes simultaneously, which I hasten to add I would not recommend, all those cars would seem to come from one particular point near the horizon, which you can call, if you like, the radiant of the motorways. Now, in the same way, the meteors of a shower are going through space in parallel paths, and therefore they also seem to come from one particular radiant in the sky. And it so happened that the meteors that represented the last parts of Biela's comets came from the constellation Andromeda. And for some years afterwards, the shower was seen regularly every November, but now it seems to have pretty well died out, and so I think we rarely have seen the last of Biela's comet. Well, now to something entirely different. On the 1st of September 1975, I went out to my observatory to make a routine observation of a variable star called SS Cygni, which is much too faint to be seen with the naked eye. It's not very far away from the brilliant star Deneb in Cygnus, and there we can see on the open cluster Messier 39, nothing very distinguished about that one. The naked eye star Rho Cygni, and SS is quite near there. Now, it was always much too faint to be seen with the naked eye, but every 47 days or so it shows outbursts, which still don't bring it up to naked eye visibility, but are quite distinct. And I remember, it's been known for a long time, and I made quite a long series of observations of it way back in 1970, when the skies were particularly clear, and from that I drew up a typical light curve, magnitudes on the left and dates along the top. And that's how SS Cygni behaves. Not quite regularly, but you know more or less what's going to happen. So, going back to 1975, I went out to make a routine observation. I looked up a Cygnus, and there was something badly wrong. There was a new star where no star had been on the previous night. And I realized straight away it was a nova. I didn't think I was the first to see it. It was so bright, about magnitude 2.5. I did make a routine call to Greenwich Observatory and said, "You do know, don't you?" And they said, yes, it was discovered a few hours ago by Japanese astronomers, and I think I was 83rd in order of priority. But it was very unexpected and very exciting. I photographed it on the following night. There it is, indicated by the arrow, and I do hasten to add I put the arrow on afterwards. But it didn't last, and within 10 days it had faded away so much you can no longer see it with the naked eye, and by now it's long since vanished from telescopes like mine. But we know what it was, and there is a link between novae and variables such as SS Cygni. Going back to SS Cygni, we know that it's made up of two stars, an ordinary star and a white dwarf. And the white dwarf, shown to the right in this schematic drawing, is a very old, bankrupt star. It's very dense and pulling very strongly. And it pulls material away from its normal companion. And that material builds up around the white dwarf, making what we call an accretion disk. And in the case of SS Cygni, every 47, 48 days, things get out of control, so to speak, and there's a minor outburst, after which the star fades back and it starts over again. But with a full-blown nova, the build-up takes very much longer, and when the outburst happens, it really is tremendous. And for a while, the star may shine hundreds or thousands of times more brightly than it normally does. And that's what happened to Nova Cygni in 1975. That was the last bright naked eye nova. When we have another one is anybody's guess, but they do happen sometimes. Now, for our next tale of the unexpected, let's go to what I call invisible astronomy. Visible light, from violet to red, makes up only a very small part of the total range of wavelengths or electromagnetic spectrum. To the short wave end we have gamma rays, X-rays, ultraviolet. Then we have visible light, and then infrared, microwave, and radio waves. And infrared is sent out by a cool material. In 1983, up went IRAS, the infrared astronomical satellite, which turned out to be remarkably successful. It operated for the best part of 1983 and mapped the entire sky in infrared. Much of the information was collected at the Rutherford Appleton Laboratory in Oxford. There's one of the dishes as I photographed it, and there is the control room. And two of the researchers there were two American astronomers, Dr. Aumann and Gillette. And they were calibrating the infrared telescope, which was on board IRAS. And they were using as a calibration star the bright blue star Vega in Lyra the Harp. And there's Ron Arber's picture of it. Vega is the brightest star in that constellation. And suddenly, they had a tremendous shock. And George Aumann said, hey, Vega has got a huge infrared excess. And what they found was a mass of cool material emitting in the infrared round Vega, the last thing they'd expected. And, well, could that be material making up either planets or at least a planet-forming system? And these impressions show just what Vega might be like as seen from close range. They then looked at other stars also. They found a similar infrared excess with Fomalhaut and the Southern Fish, and others also. And in one case, subsequently, the southern star Beta Pictoris, the infrared material was actually photographed. And there it is. So, can we say that stars such as Vega and Fomalhaut and Beta Pictoris have got planetary systems associated with them? Well, that would be going much too far, but it's not impossible, and certainly that discovery was very unexpected indeed. And then, what about phenomena which are unexpected, but which you can't actually miss? What about aurorae, or polar lights? And they can be really spectacular. And we know what causes them. They are due to electrified particles sent out by the sun, which cross the 93 million mile gap to the Earth and enter the so-called Van Allen zones of radiation which go around the Earth. The Van Allen zones are overloaded, particles cascade down into the upper atmosphere, and they produce the aurorae. And because the particles are electrified, they tend to go toward the magnetic poles, and that's why to see aurorae well, you normally have to go fairly far north or fairly far south. North Scotland's all right. England genuinely is not so good, and certainly South England isn't. But on March the 13th, 1989, we had a really brilliant display of aurora. And that was a photograph taken by Paul Doherty from Stoke-on-Trent, and from there it actually cast shadows. Now, we do get aurorae round about this stage of the solar cycle, because the sun's working up to maximum, and there had been a very large sunspot on the disk. And in fact, that drawing, made by Paul 4 days later, shows that great sunspot group now near the edge of the disk. And that was responsible, or rather the flares in it were, responsible for that aurora. But certainly it was unexpected. It's many, many years since we saw an aurora as good as that. And when we're going to have another? Well, frankly, I don't know. But the sun is active now, and therefore we may have another good display of aurora anytime within the next 18 months. Let's hope we do. And finally, what about that comet? Austin's comet, discovered by Rodney Austin in New Zealand last December. It was, and still is, fairly faint and a long way south, but it is coming north. And from March, we should start to see it. It will track up from Cetus to Pisces, past Aries, into the square of Pegasus area, and with any luck at all, in the early part of April, it could be really bright in the evening sky. And for the first time for many years, we may have a brilliant comet. Now, believe me, comets are unreliable things. Don't blame me if this one, like Kohoutek, doesn't come up to expectations, but it may well do, and we'll tell you a great deal more about it in the March Sky at Night. Meanwhile, our newsletter's ready. If you want it, send as usual, stamp address envelope to Newsletter 36, The Sky at Night, BBC TV, London W12 7RJ, or look at CFAX page 615. Next month, we're going to the world's latest and most modern telescope, so I hope you'll join me then. And so, until next month, good night.